All right, here we go. I'm going to go over this, and it's going to work as a review, specifically because I still see some of you are struggling with some of these functions, and we can't spend like more than what we've spent on them already, and by now you guys should be experts at this, right? And if not, you should have been here in tutoring, right? And what did we have yesterday? Pizza Hut. Let's go. All right, here we go. So, with that said, look at number one. It says solve for y. That's the first step. So line down the equal sign. I need to leave y by itself, which is this one. Therefore, I need to get rid of the 2x. How do I do that? Minus 2x minus 2x. We get negative 3y equals, and then I want from this point forward to keep writing it in standard form. Which one goes first? The negative 2x plus 12. All right. From there, what's the last step? Divide by negative 3, divide by negative 3. I end up with y equals negative 2 divided by negative 3 is 2/3 x. 12 divided by negative 3, that's negative 4. Hands if you got that so far. Very good. From there, it says evaluate if x equals 12. So instead of x, what do I substitute? 12. So I write y equals 2/3 times 12, and I'm going to write it over 1, minus 4. Therefore, what is 2 times 12? 24. 3 times 1 is 3, so that's 24 over 3 minus 4. What is 24 over 3? What is 8 minus 4? What is 8 minus 4? 4. What is 8 minus 4? I kept hearing 2. It's like, therefore, this is y equals 4 if x equals 12. Hands, have you got that? Okay, good?
I did it another way.
Okay, yeah, I know you could have substituted at the beginning, but did it say to do that?
No.
No, it said to do what? Solve for y first. I want to see you guys manipulating these kind of equations. Yeah, because if you substitute 12 in here, then all of a sudden you only have a one variable equation. I don't want to see that. I want to see you manipulating a two variable equation. Because from here on, like I said, it's going to get funner as we go along. Here we go. Next one. Evaluate the function f of x equals 1/5 x plus 1 when negative 10, negative 5, 0, 5, and 10. So I'm going to get a table going. And I'm going to do f of x and x. What are my values for x given? Negative 10, negative 5, 0, 5, and 10. Okay. So what is the first value that I substitute? Negative 10. I substitute in here. So this is f of negative 10 equals 1/5 times negative 10, because I substitute in here and in here, right? Plus 1. So how do I multiply this fraction times this whole number? This is over 1, so the f of negative 10 equals negative 10 over 5 plus 1. What is negative 10 over 5? Negative 2 plus 1. What is negative 2 plus 1? Negative 1, and that goes right there. Now, I did this one showing you all the work, okay? And this is the kind of work I want to see. But now that we saw the pattern, let's see. What did we do here? 10 times, negative 10 times 1 divided by 5, that's negative 2. Then we add 1. What's the next number? What's the next value? Negative 5. So negative 5 times 1, that's negative 5. What is negative 5 divided by 5? Negative 1 plus 1 is 0. What's the next value? 0. What is 0 times 1/5? And what do we have left? 1. Next one, 5. What is 5 times 1? 5 over 5. What is 5 over 5? Plus 1, 2. And then 10 over 5, that's 2 plus 1, that's 3. Hands if you got that. Okay? Very simple, right? Now, here goes in regards to relations and functions. So, an easy way of putting this is like this. Everyone in this class, all of us together are people, yes? Okay? So when you put together a lot of points like this, they are a what? A relation. Doesn't matter what kind. As long as we put different order pairs together, they are a relation. Does everybody understand that? Yes. So for example, if I was to say, all right, I'm going to put together a relation of, let's see, Emma likes, what kind of soda do you like, Emma? Sprite. Okay. Raya, what kind of soda do you like? Janelle. Root beer. Be nice. Mr. Q, one of my favorite, root beer. Yeah, especially the floats. You guys don't like? No, you guys don't like root. No, you guys. I take it back. That's only for Janelle and for me. Anyways, this is a relation. Okay. Why? Because we have for each input there's an output, and I'm sorry, because it's just a set of points. All right. So let's say now that we understand what that is. Now I'm going to check to see if it's a function. Here it goes. Without having to do anything else, just writing these down, there's an easy way of checking to see if it's a function. First things first, and write this down if you need to. Check to see if any x values repeat. Check to see if any x values repeat. Have you heard what I just said? So that's step one. Did any x values repeat? Which one? -1. So right away, when you see an x value repeat, I want you to underline that and that point, because that's what's going to tell us. That's what's going to tell us if it's a function. So check this out. Number two, the second thing that's going to tell us if it is a function, once we see that it repeats, is that they need to have the same y value. They need to have the same y value. So you know what I just said? So I'm talking about the ones that repeated, yes? So let's see. This first one is -1, -2. That means on this side, the x value is the same. Okay, here it is. Is the y value the same?
No.
Then this is not a function. And let me show you now in a different aspect, the way Ms. V presented it. Or, yeah, check this out. Didn't she show you guys a mapping diagram like so?
Yeah.
Yes, x and y. So let's see, I'm going to use this one. -1, -2. That goes to that. Okay. Now I'm going to plot this one. -1, it's already here. And what's the other output? 2. How many output values for -1? 2. That's why this is not a function. Copy this in case you want this as reference. So basically all we're doing, instead of doing the whole diagram, we're just checking by seeing if it repeats. Does that make sense? Yes. That's a good question. Let's see. X, Y. What was the first rule? To check if the X value repeated. Therefore, if the Y value repeats, then let's find out. -2, -5. Okay. 2, -5. Let's see. Does this have exactly one output? Does this have exactly one output? Yes. This is a function. If we didn't have these points right here, this is a function, yes. Why is this not a function? Because for one input, there's how many outputs? 2. This one input has how many outputs? 1. This one input has how many outputs? 1. So this is a function. Talk it over with the neighbor and let them know the difference between this one and that one. Sure. Okay? All right, show me with the fingers how comfortable we are right now with relations and functions. Okay, so hopefully we settled that matter, yes? Is it a little bit easier to check like that? Yes, all right. So set that aside, please. Get your Cornell note in front of you. I gave you guys a Cornell note. You are going to need also the graphing paper, so get that in front of you also. We're moving on to funner and greater things. Yay. Our objective for today, I can solve and graph linear functions. Read together. 1, 2, 3. I can solve and graph linear functions. So, our concept for today, we're no longer on arithmetic and geometric sequences. We're in linear functions. And today we're starting with graphing again. Now, graphing you've been doing since 4th grade, I believe, something like that? Yes? So definition for linear functions. Here it goes. A linear function is a relation that assigns exactly one output value for each input value in 2 variables and has a constant rate of change known as slope. Hands if you heard of that before. Yes, you've heard of slope before, yes. Now, here they bring in what I explained earlier right now, a relation that assigns exactly one output value for each input value. That's why the very first example I gave you was this. Look at this. What is the first thing that we're going to check for? See if any of the x values repeat. Tell you never which one repeats. Does it have the exact same y value? So this is a function. Everybody understand now? Yes. The whole thing's a function, yes. The only reason I only check those 2 points so you guys can see how one input gave us 2 outputs on the previous one. Okay, yes. The previous one was not a function because of those 2 points. For this, so you would, if they're asking you to check to see if a function, all you have to do is this. Okay, this one and this one. So then you would do this. -2, 3. And you just write yes, function. That should be enough work for me. So the question was, does it make the whole thing a function? Yes, the whole thing's a function. All right, next. Copy these examples down of linear functions. F of x equals 2x plus 1, y equals -3x plus 4, and y equals 2/3 x minus 23. So all these are examples of linear functions. Now notice here I interchangeably used f of x and y. Why do you think that? Because it stands for the same thing, right? Y is the function of x because x is usually the input value. Are we there so far? All right, so here we go. So these are examples. Now look how particular they are. Here it is, here it is, here it is. Okay, for non-examples, I gave you this one. Turn to your neighbor, let them know why this one is not a function, please. Yes. Denise, why is that one not a function? Because it has 2 repeated x values is not quite correct because this one also has 2 repeated x values and it is a function. So can you finish it out? Because it has 2 repeated x values and the y is not the same. Hands if you agree with that? Yes. So this one, the -2 repeats, but the y's are different. All right. Then I gave you a diagram. Is that correct? Yes? Now check this out. Look up to the screen. I'm going to zoom in. Writing utensils down. Here we go. So you're going to miss it. Let me show you why this one is not a function. There's two ways of checking this. The first way is choosing a x value, which is the easiest x value that you see here. 0, or how about this one? I'm going to choose -2. Okay, -2. According to this graph, -2 is on that graph at what y value? What y value is this? It's 1. So this is -2, 1. You guys see this point? It's on the graph. Okay. Now let me go around. Is there another point using the same x value? Yes, this one right here. What is the y value of that? -2. So that one is -2, -2. So now, if I was to make one of these, this one has -2 and 1. There it is. And this one is -2. It's already written there. I don't repeat it. And what is the y value? -2. How many output values does this one have? 2. That's why this is not a function. Now, another way of looking at it, look up, please. Here's a point. Here's a point. Something that we call a vertical line test. Let me show you a vertical line. Let me make this a little bit bigger. I'm going to use blue. Here's my vertical line. I'm gonna scan this graph like the Terminator from left to right, and as soon as this line touches that graph in 2 spots, that tells me that the x value has 2 points on that graph. Here it goes. First, let me show you the -2, which is, oh my goodness, the -2, which is obvious. Here's my vertical line test. Do you see this line touching here and here? That's why it's not a function. So let me show you. Is it touching there? Both? Yes. It's touching the graph, isn't it? How about there? There? Yes. Yes. So therefore, if it touches all the way through, that's why it's not a function. Some of you are like, I don't see it, Mr. Q. Well, all these invisible points here, in order to make a line here or a line segment, don't we have to have a lot of little points in between? And if I have a lot of little points in between there, I have them also over here. Now let me use my line. Is it touching 2 points here? There, 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 and all the way through. The only spot it doesn't touch 2 points is on the vertex, which is on the corner right there. You guys see that? So therefore, that's why this is not a function. So, question, comments on that? We good? All right. Next, copy some more non-examples. Copy these. Y equals x squared plus 4 and y equals x cubed plus 1. Y equals x squared plus 4 and y equals x cubed plus 1. Copy that. All right, so look at the non-examples, the last ones I gave you, and look at the examples for linear functions. Non-examples, linear functions, non-examples, linear functions. Tell your neighbor why these are not linear functions. Okay, I hope everybody said because they have what? Exponents, what? Greater than 1. Now check this out. Once we get to these, because we are going to get to these before the end of the school year, let me show you what this graph looks like. It's not a linear function, but this is a quadratic function, and it looks like this. Sketch it right next to it. And this one is called a cubic function, and that one looks like this. Whoa. Ha 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 ha. Be nice. All right, we got it? So with that said, It says the linear functions are a relation that assigns exactly one output value for each input value in two variables, and that has a constant rate of change called the slope. Okay, so with that said, come up with a couple hashtags right here of what a linear function is. What a linear function is. Hashtag something, hashtag something. And no, I don't want to see hashtag math. Hashtag school. Wow. Hashtag gummy bears. No. Okay, volunteer. Hashtag. Nayeli, go. Hashtag no exponents greater. I'm just going to use a greater arrow and 1. Really? Daniel, let's go. What? No. Let's see, another. Lauren. Hashtag relations, okay. Emma, hashtag same X value. And bam, same Y value. Pretty good, yes? Oh, and last one, hashtag bam. Wow, Raya, be nice. So if that doesn't count, wow. Hashtag mean. All right, right. Did I give you the steps already? Here go the steps. It says, step 1, write a rule for the function. Okay. Step 2, graph the function, solve for y first, and use an input-output table. Okay. Step 3, test your graph to see if it's a function. Do we know how to test it now? Using what? The vertical line test. Okay. And step 4, evaluate the function after writing in function notation. Okay. Evaluate. Does everybody understand what the word evaluate means? When you substitute the x values in, and then you simplify for the other variable, yes? All right, so with that said, here's some examples of linear functions. They use it usually to show graphs and distinguish two rates, one from the other. Are you guys okay over there? Yes? All right. Anyways, tomorrow as we continue with graphing, today we're looking at linear functions. Tomorrow we're going to continue with linear equations. You're going to see the similarities between both. So, first, in the back of your Cornell notes, copy... Actually, no. Get the graph paper in front of you and get the big graph paper. At the top left, I want you to write example 1A. On the big graph paper. My goodness. You guys want some coffee or something? No. So on the big graph paper on the top left, I want you to write example 1A and write the instructions. Graph y equals 2x plus 1 and tell whether it represents a function. Now, as you're copying that at the top left of your big graph paper, and by the way, the numbers should be read, you know, if you're reading, they should be up, right side up, right? If you have it upside down, then turn it around, yes? Yeah, because some people have it upside down. All right, here we go. Next, really quick, as you're finishing copying the problem, let me recap on why we use, bless you, this kind of graph-to-graph equations. Look up, please. Now, maybe this introduction, they didn't do that in the past, but I'm going to do it this time. When we first started at the beginning of school year, we started with expressions. Oh, I'm sorry, real numbers. We went to expressions from there to one variable equations. What did I ask you to do with one variable equations? Plot your point. Is that correct? And we started off with this line. Look up. Boom. This is a real number line, and it represents the x value usually, right? But now that we are in two variables, of course, we're not going to do this. This one's for one, and this is for the other. Well, guess what? There's people that think like that, and that's why I want to clarify. I mean, this will be obvious. Is that correct? Some will say, well, can't I just label one x, one y? Yeah, but people are going to get confused because they don't see, you know, the coordinate in regards to that. Well, someone back then, a mathematician called Descartes, he figured out that in order to make coordinates work, he needed two variables, and he needed to use two number lines. But instead of using them like this, he said the second one, we know that, oh, by the way, this first one, we know that if we start here at 0, everything to the left is what? And everything to the right is positive. Same thing with this one, but he said, you know what? I can just take this second one and do this. That's why from here, this way, they are all what? Negative. And from here up are all? So basically all I did is this. I took the number line and I moved it like this. Does everybody see that? All right, let's see if I can wrap these two. Hold on. So I went from here. Look at the x-axis. All the positives on the right, yes? If I move it like this, where are all the positives now? On top, and all the negatives on the bottom. Does that make sense? And that's why we use this. The mathematician was known as what? Descartes. And his last name is spelled, or it's written Descartes. It's pronounced Descartes because he was French, or yeah, something like that. And guess what? That's why this is also known as the Cartesian plane. Do you guys see that? The Cartesian plane, also known as the coordinate plane. Why did we call it now coordinate plane? Because now anytime that we place a point, we give coordinates. Kind of like saying, oh, I'll meet you at the corner of Donut Avenue. Well, yeah, give me directions, please. What is that other street? What is that street? G? And what's the one crossing? What is the one crossing that goes to the high school? What is that one? Imperial? Is this one the one that comes to correct? Right. Never mind. Anyways, you get the idea where it comes from, yes? Okay, now that we gave a formal introduction to the coordinate plane or Cartesian plane, let's graph, because they're asking us to graph. From this point forward, let's assume that I'm giving you a domain. Any numbers that I give you, we're covering all the points in between. But I'm only going to give you 5 numbers to use for the domain. And the domain stands for all what values? X. So let's make a table. X, Y. For the domain, I want you to use from this point forward, -2, -1, 0, 1, 2. Everybody's copying this, right? Okay, good. Now, we're going to get our equation. I'm going to write that right next to it. Y equals 2 parentheses plus 1. Why did I make it parentheses? Because I need to evaluate this equation using all these values. So what is my first value that goes in there? I'm going to use blue. -2. It goes in here, -2. What is -2 times 2? Y equals -4 plus 1. What is -4 plus 1? -3, and that goes right there. Next value, -1. So if I substitute -1 in here, we get what? Y equals -2 plus 1. Is that correct? Yeah, -2 plus 1. What is -2 plus 1? negative 1. That goes right there. What's the next value that I'm going to substitute in here? 0. So y equals, what is 2 times 0? 0 plus 1. What is 0 plus 1? 1. That goes right there. What's the next value? Positive 1. So what is 1 times 2 or 2 times 1? Y equals 2 plus 1. And that is 3. That goes right there. All right. And our last value is 2. Substitute 2 in here. What is 2 times 2? Y equals 4 plus 1. What is 4 plus 1? 5. All right. Now that we have our values, let's plot these. Here we go. So I'm going to start with this one. Now I'm going to plot it in an easy way for those of you that struggle with plotting, so you guys can understand where to start. I'm going to start from the point of origin, which is 0, 0 in here. It tells me to go 2 which way? To the left. Yes? 2 to the left. And then the y value tells me to go 3 which way? Down. So I plot my point right there. Started here. I went 2 to the left and 3 down. 2 to the left, 3 down. Okay. Next one. I started at the point of origin. It tells me negative 1 to the left and negative 1 down. So it's right there. Next one, I start at the point of origin, which is 0. Do I move anywhere? No. And it tells me to go 1 up. So I go up 1. Next one, I start at the point of origin. It tells me to go 1 to the right and 3 up. 1, 2, 3. Plot my point. And the last one, it tells me, I start at the point of origin. It tells me to go 2 to the right. 1, 2, and 5 up. 1, 2, 3, 4, 5. Okay, and at this point, I do want you to draw a line going through those points, please. Nice and straight like mine. Now, I had given you index cards in the past, didn't I? Okay, good. You can use your index cards. Yeah, you shouldn't have thrown them away, right? Yeah, no, you didn't throw them away. All right, here we go. So with that said, first let's check to see if this is a function, but using the ordered pairs. Look up, look up, look up, look up. I want you to do this. Is this an ordered pair? 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 Do any of the x values repeat? Therefore, this is, yes, a function. So we checked it first by using the ordered pairs, right? Now let's check it using the vertical line check. And how do you do that? You can actually get your pencil and scan the line that you just drew. Yeah, like the denominator. I mean the terminator, sorry. Let's scan this. Let's scan this from left to right and see if my vertical line or your pencil or your pen as you're scanning it, go from left to right. See if it touches at more than one point on your line. Let's see. Does it, look at this one. It touches only at one point there, at one point here, 1 point there, 1 point, 1 point, 1 point, 1 point, 1 point. Therefore, this is a function. We got it? Okay. Now, you have space to the right of your graph, don't you? At the, let's see, we got 1, 2, 3 on the fourth quadrant. Okay. Down here, check this out. Right here, I want you to do this. I want you to, we're going to go start at -4 and do this. Go up like so. And then do a little squiggle like this. And then go back up to the +1 like that. And then put arrows at the end. Okay, so we started at -4. You went this way to like about 2. It doesn't have to be exact. And then come back like this to about here. And then go back out that way. Now check this out. Let's check this one without writing our ordered pairs. Let's check it using our pen or our pencil. Vertical line test. Here he goes. Let's scan it from left to right. Let's see. Is it a function there? Yes. Yes. No. How many places does it touch? 1, 2, 3. This one is not a function. Tell your neighbor why that one is not a function, please. So yes, this one is not a function because it touches, my vertical line test touches here, guys focus, here, and here. So this one has 3 different values, y values, for 1 x value. Does that make sense? All right, so with that said, do we know our 2 different ways of checking to see if it's a function? Yes, using the what? Ordered pairs check or our vertical line check. Pretty simple? All right, so turn your graph paper over. I want you to do this next one by yourself. Yes. All right, here we go. Here we go. Copy this one at the top left of your, there's smaller size, right? Yeah, at the top left, copy this one, example 1B. Focus. Here we go. Don't copy the instructions, just copy the equation. 15x plus 3y equals 9. As you're copying that, let's see, step number 1. Mackenzie, can you read step number 1 from the Cornell notes, please? I'm sorry? Okay, this one already has one. Step 2. What did she say? Graph the function, solve for? Is this one solved for y? So guess what? That's the first thing we're going to do. So I'll get you started. Here we go. First thing you do, let me cover this. Line down the equal sign. Tell your neighbor the first thing you're going to do if we need to leave the y by itself. The y by itself. Everyone, subtract 15x. That is correct. Subtract 15x. Subtract 15x. We got 3y equals negative 15x plus 9. And then at the end, everyone, divide by 3, divide by 3. And we're left with y equals negative 15x divided by 3. That's negative 5x. Positive 9 divided by 3. That's positive 3. And this is the rule that we're going to use. Do we know what to do from there? Yes, get an input-output table. X, Y. And what domain do we use? Tell your neighbor, please. Very good. Negative 2, negative 1, 0, 1, and 2. And do you know how to fill this in? Yes. Good. Fill that in, please. Plot your points and see if that's a function. Yes. Use this one. Everybody hear the question? Do we use the original equation to evaluate, or do we use this one? Use this one because if you substitute in here, you're still going to have to manipulate in order to solve for y. Does that make sense? This one's already solved for y. Who got 13 for the first value? Okay, good. Who got 8 for the second? 3 for the third? Okay, and by now, look up, you should see a pattern. So what's the next value, everyone? Negative 2 and negative 7. All right, just by looking at this, is this a function? Yes. Yes. Function. Function. All right, finish it off. Let me forward this because I want us to get to this next part. So really quick, we're going to be looking at different forms of equations. The one that we are looking most commonly right now is y form because we solve for y, right? But the other form that I want us to get used to is this one, standard form. And standard form looks like this. AX plus BY equals C. This is standard form of what? What are we using right now? Linear equations. Standard form of a linear equation. Copy this, please. On your Cornell notes, underneath the steps. Last one, right? Example 2A. I know, we got to go. But right, standard form, AX plus BY equals C. And then right next to it, or below that, you're going to write X equals 2Y plus 4. Question. Can we identify that this is not the same as this? Does it look the same? What do I need to do to this one so they can look like that one? Everyone? Move the Y to the other side. Who noticed that for standard form, X and Y are on the same side? Yes. Subtract 2Y, subtract 2Y. X minus 2Y equals 4. Now, with that said, once we have it in standard form, tell your neighbor what A is, what B is, and what C is. What is A, everyone? No. What is A? 1, because there's an invisible 1 here. What is B? -2. And what is C? 4. And that's all you're going to do for that part. Got it? Pretty good? So the home play, you got a play sheet from the back. Play sheet, what is it, 5 point what? 5.1. Only do both sides, please. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye.